Hello everybody, in this section we are going to explore different functions in the Matplotlib. So let's dive in. So guys, since we are working the data, actually the main idea of this tool is working with the data, and we need to come up with the data. So the features that we are going to learn today, we are not going to explore anything from outside, like we are not going to use any sources from which is from outside. So we are going to go ahead and generate our data by themselves. So that's why we need some libraries. So the first library that comes to our mind is a NumPy. So I will just import my NumPy as np. Let me run it, and here we go. Oops, what I did. Okay, so I need to say import NumPy as np. Now I need my second library, that is the Matplotlib. So what we did last time, I will do the same one, and I will show the second way how to make it. So for example, I will say from the import Matplotlib as a pyplot and as a plt. So let me just explain what is going on here. I will get my pen. So we have a library Matplotlib. Let me just illustrate here. Let's imagine that is my entire library. So I have my Matplotlib, and inside that library we have a different function. So we have a function 1, we have a function 2, or if you want, you can call it's a sub library. So we have another small libraries that is under the main library. So we have a library 1, we have a library 2, and inside that library we have a different function. So we have a function 1, we have a function 2, we have a function 1 and 2 here. And inside those functions, we have a different methods. It looks like we have a codes inside of codes, and all of them are organized. So what we are telling the Python, hey Python, now from this library, I don't want to have anything because Matplotlib is a huge library and it has a lot of functions. So in order to keep a little bit easy and do not overload our system, I'm telling that, hey, can you just bring the pyplot only? I don't need all of them. And imagine that is my pyplot. So I need these library only from entire Matplotlib, and that this is the PLT as a short way to use it later on. So I can run it, or in a different word, what you can say that from a Matplotlib import pyplot as PLT. It's the same. So it's up to you. So which way do you prefer? So both of them will be safe. So here I'm telling them from this library, just bring me that one only. And from another wording, I say that from the Matplotlib library, import the pyplot only and put it short way as a PLT. You see, it's the same. It's absolutely same. It's up to you which way do you want to use. Perfect. So what I'm going to do is, what is our plan for today? We are going to generate a data, and I will try to make it generate a data which is a little kind of usable. Instead of saying A, B, C, D's, I can bring some real scenario. So we are going to work with the students. So I will be having the students' names. So let's imagine I have a student A, I have a student B, I have a student C, and we are going to have more students. And after that, I have some math grades, and I have, it's up to you. If you want, you can say English grades or physics grades. Let me just say English. So and after that, I'm going to generate random numbers. So I will say student A gets from the math class 55, and student B gets 100, student C gets 97, and for the English classes I will say 67 here, that is 80, and that is 75 here. So what I'm going to do is I need three my data. One of them students' names that I cannot generate it randomly, so I will input it manually. So I will call them one by one. But these math and English, we are going to generate these numbers randomly using the NumPy library. So I will ask NumPy, hey, can you help me? So instead of going and typing them one by one, I will be using the NumPy library to generate them. The only thing I want to make a rule that my all grades will be something between 50 and 100. I don't want to go below the 50 and more than 100. So this is my range. Okay. So far, so good. So let me start from the names. And after that, we will go to the math and English. Perfect. So since the names, they cannot be generated randomly, and I will do it manually. So I will say names is equal to, and I need my list. So Right now, I will be creating 8 students. Why 8? I can make it 3, 4, but as much as we have a student, so we will see how it reflects on the graph. So it will be nice to see more students in the one graph and see how they behave in terms of grades. So let me just put 8 different names. So 1, 2, 3, oops, 4, 5, 6, 7, 8. Perfect. Now, let me just, if you want, you can give the real names like Alex, Mike, Joshua, Oscar. But what I'm going to do is, let me just call it student 1. Okay. And what I'm going to do is, let me just copy paste it here. I will say that is my student 2. It takes time in the beginning, guys, but you will get oops. I will just make a nothing to do. You see, guys, so we need to do it manually. I wish we had a function to make it randomly. Or if you want, you can challenge yourself and make it small scripts that is going to generate them randomly. But I will do it manually. 2 more left, guys. That is the 7, and 1 more. That is the 8. Perfect. So right now what I did it, I have my list of names, and names are here, student 1, student 2. And later on, if I need to call my names, and all my names are here. Perfect. So we are done with the first data set. What about second one? Now I need my scores, grades for the math and for the English. So let me call it math. So I could go ahead and do it manually, but let's use the NumPy. I will say from the NumPy and from the random function, I will use random integers. You see, that is my library, NP. That random is my function, and that is my another function, method. So if you are wondering what I need to put inside, if you put these parentheses, guys, it will help you what to do. It says that, hey, you need to put what is your lowest number and what is your highest number and how many of them you need. Wow, that is cool. So what I can say that, let me put a 50 and 100. So I want to put all numbers between and 100, and I need my 8 names. Perfect. You see, so right now it didn't give me error. It says that it was generated. So I have my random numbers. So right now, if I call it, so all my numbers are here. Perfect. That is, I have a 1-dimension array and my numbers are here. So let's do the same way with the English, because I have my second data. So the only thing, I will just say the English here. Let me just type it all of them, English. And I will tell it, hey, can you, oops, let me just run it. Now I will tell it, hey, can you print for me math and English, just in case. I'm just double checking if that was generated. Oops, I misspelled. Let me just delete one more time. English. Perfect. So, and let me put the names here so I can see what I did so far. So I have my names, I have my math, I have my English. Let me just run it. Perfect. I have my data. So those are my names, and those are my English. Yes, that is my math scores, and that is my English scores. Perfect. So we are done with the data. And later on in the next our activities, guys, we are going to work with the real data, but now we need to have a small data only, because the main idea of this session is to explore new features in Matplotlib. Okay. So we are going to dive to the object-oriented, because that is important, guys, and we need to get used to the object-oriented, because later on, whenever we are going to do the capstone project, guys, you are going to have the huge data, and those data will be changed at any time if needed. Okay, so the number one is I need to make my canvas. Do you remember that in order to create a canvas, I will say, from the PLT, I need to save figures. Okay, and let me save that all of them to the fig. I'll just give this. Let me just create an. Oops, what is happening? PLT figure. It's just only figure. It's without S. Perfect. So What is the idea of that? I know it looks like in the beginning it doesn't make sense why we are doing that and why we need it. We already covered that in our previous session. So right now I'm telling my Python, hey Python, just keep in mind that I need a canvas, and later on I will be having my graph that I want to put my graph on this canvas. Maybe I will be having one graph or two or more. So and it says that it was created and the size is 432 and 288 as a default. Okay, that is good. So right now what I'm going to do is I need to say that from the figure I want to add axis, and that is a little bit tricky too. So let me just open and I will just do 0.1, and I will explain just in a second. I already did it last time, guys, but I will go over one more time because I feel that that is important and that is the most confusing part. And let me save that all of them to my axis. I'll just explain in a second, guys. So what we did here, I will get my pen, let's go and explore. Now, in the first line, we told the Python that I need my canvas. So this is my canvas. Okay. The first time that we ran it, it didn't show up because we didn't had any graph to put on it, but it was created. It was not visible, but which is fine. Now I want to make my graph. If you want, you can call it ABC, or you can say this is my first picture or first graph. I just call it axis, but if you want to do on my canvas, on my figure, I want to add axis. Okay. And here we have 4 different values. 1, 2, 3, 4. So the first one is, by the way, all these numbers, they must be between 0 and 1, between 0 and 1, no less than 0 and no more than 1. So you can put like a 0.12, you can put a 0.75 and so. So what does it mean that? The 0 stands, it's a 0% and 1 stands at 100%. Okay, if you put a 0.5, that stands for the 50%. So whatever you put here, let's imagine I have a 0.1. What does it mean? That is a 10%. That is going to be 10% away from my x-axis. Why we are doing the percent, why it's not pixel, why it's not inches or centimeters, because it depends on what is your canvas size is going to be. If you are going to resize your canvas that we are going to do today, imagine that we are going to resize our canvas, so we still need to have a 10% gap here. And I put another 0.1. You see, I have a 0.1 and 0.1. So I need my 10% from here and 10% from here. So my graph will start drawing from here. So that is my coordinates of my graph. Okay. And what about that 0.8, 0.8? Basically, that is 80%. So that I want to say that, hey, I want to make my graph that is going to cover 80% of my canvas. So this is my canvas, and my graph is going to cover 80% of my canvas. So the first one is represent the width, and the second one represent my height. So that is 80% of my canvas, and that is 80% of my height of the canvas. Okay, so far so good. Perfect. So this is the canvas that we just created. Perfect. That is good. Now, later on my axis, I want to plot some graph. You see, so far we don't have anything over here. So let's start. Now, I need to plot my data. And where's my data? My data is here. So let's start with the names and the math only. So, and right now you see I open a parentheses and the system is trying to help me. It says that, hey, you need to put the x value first. So put these numbers first, and after that y values. I want to place my names here. So I will say I want to put the names here. And on the y-axis, I want to put my math scores. Yes, guys, cross the fingers. Perfect. Yes, that is good. You see, guys, you need only 1 or 2 seconds just to see who is getting the highest grade and who is getting the lowest grade. So that's why to have the visual graphic, it's very important for us. We have only 8 students, but can you imagine if you have 800 students, and if you see all grades, guys, so you can easily identify who is passing or who is failing. And you can put the line over here and you will just see that who is failing that class. perfect. So that is a behavior of the class. That is amazing. Amazing. So let's imagine that I want to plot my English scores too in the same plot on the same graph. Okay, that is fine. I will say on the axis I will plot names and English too. So let me plot it. Oops.
You need S for the names.
Yes, I misspelled. Yes, guys, thanks so much for helping. Let me plot it. Yes, perfect. That is amazing. That is amazing. Let me just go ahead. And if you are in a management team, so you can say that a student A is struggling in one subject, but he's very good in other subject. So these students is very good in the both subjects. But we have some students who are, so for example, that student 5, he is in average in both of classes. You see, so it will help you to analyze two data in the same time. That is perfect. So let's go ahead and give some titles. So I will say that on my axis, I will set my title. And this is students report. And in your assignment, guys, you need to put your real name. Okay, I just putting my real name, but I will ask you to put your real name because we are going to download it and you need to submit it. And let me just run it. Let's see how it looks like. So yes, I have the student's report and my name on it. After that, I will say axis and set X label, and I will put students' names, and on the Y axis, I will say set Y label, so grades. Perfect. Oops. Let me just run it. That is amazing. Perfect. So we are done. Actually, you can feel that we didn't learn that much new. The only one feature we added is just a second data. Now, what we can do at this point. So whenever you are going to print that one, or imagine that you want to send this report to somebody else, and you are going to report, let me just get my pen, and you are going to send this picture only. Okay, I got this picture. But the big question is, what is a blue line stands for, and what is that orange line stands for? By the way, we can change those colors, but it doesn't give me any information what is that for. So I need somehow like some another notes here, or like in deep notes, or saying that hey, the blue line stands for something, and for the orange is dedicated for something else. So how we can do that? So we are going to explore another feature here. Do you remember that we just plotted here names and math? And also there is another variable that I can say label is equal to. And let me just label that it's math scores. And for here in English, I can say label is equal to, oops, that is my English scores. Perfect. If I run it, it didn't give me error, which is okay, but it didn't pop up here. I cannot see, nothing has been changed on my canvas. So in order to activate them, in order them to be on my frame, what I can say that I will say PLT legend. So there is another new functions that we are going to learn today, that we are learning now. It's a legend. So that means I'm turning on all my labeling. So I have a label 1, label 2. So this label is a different that label. So this is labeling my coordinates, and this is labeling my data. Okay, so if I run it, cross the fingers, perfect. Now it shows me, you see, it gives me detail. So I have my English score, which is orange one, and I have a math score, which is my blue one. Perfect. That is amazing. What if you want to regenerate your data? So if you want to regenerate, I will just click it one more time. You see, so right now I have another data because it was regenerated. And later on, if I just run it, it will give me another data. Wow, perfect. So I can see clearly here the student 1 is good enough in both subjects, but student 2 is very bad in 2 subjects. Student 3 is average in English, but is very good in math, and so on and so on and so on. Perfect. What is next? What is next? So let's say, guys, do you remember that in the beginning when we made our canvas, it was telling us that the canvas was it's 400 pixel or something. So because we didn't specify anything inside, and if we do not specify, we are telling Python, hey Python, can you figure out by yourself? So just make a canvas and that's it. But if you want to do by yourself, what you can say that it will figure size. Fixed size. So that means I am telling my Python, hey, what is my canvas size is going to be. Why it's important? Let me just go ahead and explain here. Let's imagine you are working in a company and you will be working as a team. So we have a company here, we have so many people working here, and every department, they have a duties. And let's imagine this department is just designing a website. So they're responsible to make a very interactive design and so on and so on. And they will tell you, hey, we have our website and we are planning to put this graph somewhere here only. So here is the dimensions n, x, y. And they will ask you, hey, do not make it bigger and smaller. Just these is the only dimensions you need to use. So that's why we need to go ahead and make some modifications on the canvas. You see? Or they will tell you, hey, it will be showing here. So whenever the user from outside, whenever they click on this graph, we want to show this graph as a full screen. So right now I will be having my another dimensions for my graph. So how I can change it? How can I make my custom size of my canvas? So right now what I will say that, hey, figure size, and I need to give a list parentheses. So what is my x value, what is my y value, and it counts as an inch. So let me just say 6 by 4. If I run it, yes, it gives me 6 by 4 right now. And what if I will do a little bit bigger? Let me put it 10 by, let me put it 6. So if I run it, perfect, guys. You see right now I have my bigger size, which is absolutely fine, and you can do as much as you want. You can do like 500 by 400, so you can make it huge. And also, I'm not sure if you see on your screens, guys, but whenever I zoom in, I feel it that the pixelation is not correct. Do you feel that it's not a straight line? So it's all about DPI. And what is the DPI stands for? So if you are working with the Photoshop, if you are working with the graphical design, so you know what the DPI stands for. So DPI, it's dots per inch square. So I have my inch square and how many dots I have inside. Okay, so as a default, if you do not specify what is the DPI, actually DPI is the same as a resolution. Because some of the screens, like the users, they are using a 4K screen, and if you give this picture to that user, so it will be not nice because it's a little bit bluish. But we want to make it perfect, so we need to have more resolution. So if you do not specify, the Python will come up with some defaults, but I will tell that, hey Python, I will do it. So let me just go ahead and I'll say DPI is equal to, let me put 100. And if you run 100, now it's much more clear, guys. Do you feel that one? It's much more clear. So let me go ahead and change it one more time. So let me just make it 500 DPI. That means it's a 500 pixels in 1 inch square. So if you run it, it will be a little bit bigger. It takes time. Now guys, I can see clear. The lines are so nice and they are perfect, and yeah. So I will just delete the DPI for now because we are going to use the DPI in our feature function that we are going to do just in a second. Perfect. So this is my graph. This is my graph and it's easy and it's ready to use. What is next and what is last? So right now, imagine that you are done with all your settings. So you have your data, you just converted to the graph, you have your canvas, you did all your labelings, you did all your explanations here, all of them are good. The only thing is you need to save it in your local machine. Right now, it's not a local machine, we are using a Google Colab, it's on the cloud. But if you want to save it somewhere in your local machine and share it with somebody as a report, we need to download it. Okay, so right now I will say from now, let me just zoom in and you will see clearly what is going on. I will say from my figure. What is the figure? That is my canvas. I want to do entire my canvas, and I will say save figure. Uh-oh, okay, it is going to save for me, and I need to give the name. So save as what? Let me just say my report, or just report. And also we need to specify what is the extension is. That is also important, guys. If you do not specify the extension, it will be just a little bit messed up. So you can say that save my file as a JPEG. That will be picture. Save my file as a PDF. That is fine. Save my file as a PNG. That is another format for the picture. So this is a picture, but this is a picture, but this picture is a little bit kind of more, it has a more higher quality. So it's either like, so you can use the either one, and all of them will give you the same result. So I will be using the PNG for now. So if I use the PNG, let me run it. Perfect. Something happened. It didn't give me error. That means something happened, but the question is, where is my file? So if you are using a different IDs, if you are using not a Google Colab or something else, so it will be download to your computer somehow, or it will give a message that your picture is ready. But in the Google Colab, what we are going to do is we are going to go to that folder. Let me just go to that folder, and you see, my report is here. Perfect. It was generated. And let me just go ahead and I will download it. And it's already here. It's on my computer now. And if I just run it, it's on my second screen. Let me bring it. Perfect. That is my picture. It was saved on my computer. That is amazing, guys. You see, so I have all my reports. And that is amazing. It's ready to be used. And also, so we didn't specify anything else. So we just say that, hey, save it as report.png. But if you want, you can just add different specifications. For example, I want to know what is the DPI is going to be. So let me put the DPI as a 600. You see? And if I run it, it is going to generate me my new report. Let me just refresh it one more time. It takes time because a 600 DPI, it's not easy. So let me download it. Let me open it. It will be on my second screen. And yes, it's much more bigger because it has a 600 DPI. And it's so perfectly, so I can see all my students' names and all my grades, and I have my graph here. And if you're wondering what else I can add, so you can go ahead and analyze this website, Matplotlib, it's a website of that library. And if you just search it, save file, and they will tell you what else you can do. So we just made a file name. And also what you can do is, it's a face color, you can go ahead. So those are defaults. You see, so if you do not specify anything, so those are default. So for example, transparent, it's a false. So let me bring the transparent to the true, and let's see how it's going to look like. If I say that transparent is a true, that is a boolean, let me just run it. So what does it mean, transparent true? That means do not make any color here. So whatever is my background, just show my background, and show the lines only. I don't want to see this background. Okay, so I hope it just generated properly, and I'm going to run it. Let's see. Perfect. I can see my reports. You see, now I have my transparent true because whatever is my background, and it gets as a default. But it's hard to see what is my student's name, what is the grades, but you can go ahead and change them. They have a lot of features. And to explore those features, guys, you can just go ahead and read it from here. So the DPI, the quality, you can change the quality, you can optimize it, and so on and so on and so on and so on. It's not that much extremely important. It's just to make it a little bit nice view, and that's all. Okay, so I think I'm done for today, and